after someone knows the basics of graphing by plotting points, which is pretty straightforward, the only real mistakes that can be made, which is where I would say probably 90% of the mistakes are made in graphing, are made by simple mechanical mistakes, such as what I discussed in the previous set of problems where we were talking about order of operations. So I thought I would do two more really. One to kind of talk about possible mistakes that can be made with the properties of exponents. And I thought I would do one with a radical as well, because while you learn about radicals in earlier algebra classes, I remember myself personally, I never really spent that much time on them. So I thought I would just throw in a problem there in case someone had not either done any or it had been very long time ago and quite brief. So let me do the first one. It's a relatively simple one as well if you know the properties of exponents, but if you haven't seen them for a while or never really learned them properly, then it might give you a little bit of trouble. So the problem I picked out is y is equal to x cubed. And in the previous examples I've used x squared, but this time I'm doing an odd power. So let me go over a couple properties of exponents just real quick. So if we have x squared, that is the same thing as x times x times x. Correct? So if we have a negative number, so if we have negative 2 times negative 2, or let's just change it to 1 so we can just, I don't even want to bother multiplying. Negative 1 times negative 1 is equal to negative 1 squared. And that is equal to positive 1 because a negative times a negative is a positive. And it's the same thing if we had any even number of exponent. So if we had x to the fourth, that is minus 1 times minus 1 times minus times minus 1 times minus 1, which is equal to minus 1 to the fourth, which is still equal to positive 1 because you get minus 1 times minus 1, which is positive 1, times a minus 1, which then turns it to minus 1 again, times another minus 1, which makes it positive. So where I'm going with this is sometimes people may forget that in even powers, or I mean in odd powers, so let's do minus 1 for x cubed. So minus 1 times minus 1 times minus 1. Somebody might make the mistake of just remembering that, because when we do problems we don't generally see higher order functions that much in lower level math classes because we just don't have any practical use for them, and in fact you probably won't see them that much in college algebra or pre-calculus. Not until you get to calculus and differential equations will you start making regular use of them. But anyways, here we have minus 1 times minus 1, so that's positive 1, but then we times it by another minus 1, so actually a negative number cubed is a negative number. If it's positive, positive 1 times positive 1 times positive 1, it's still positive. But the difference is any negative number that is raised to an odd power, so it could be 3, 5, that's bad, 5, 7, 9, etc. When there is a negative number, it will remain negative. So that is a common mistake that can be made. So let's do the graph of this now that we've gone over that and know that. So let's first make the table. Y is equal to x cubed. Now we'll do same numbers we've been doing. So let's begin. Y is equal to negative 2 cubed. So that's the same thing as negative 2 times negative 2 times negative 2, correct? Which will be a minus times a minus times a minus. So that's going to give us a minus answer. So 2 times 2 times 2, that's 8. So it's going to give us minus 8. So minus 2 minus 8. For minus 1, we already did this one. So we'll just kind of go through that one real quickly. Remember, a minus times a minus times a minus. So that's 3 minuses. 2 minuses cancel out. Times you have 1 minus left over. So we have minus 1, minus 1. And the rest is pretty straightforward. No speed bumps or murder holes or anything like that up ahead. Oh, that's a 2, not a 1. So now we have all our information. Let's just stick it on a graph, and we'll be done with this one. So as you can see, in almost all math classes, it's really the ideas that you learn in the class that are supposed to be more advanced are usually really not that difficult, and what usually gets everyone is just the basic either algebra or basic number properties. So it's really important that you spend time on those and make sure that you know them really well, because more often than not it's going to be one of those things that you should know already that's going to get you in math rather than something new that you learned, oddly enough. So our first point is minus 2, minus 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'll put an 8 on there. Second point is minus 1, minus 1. Third point, 0, 0. Fourth point, 1, 1. And the last point is 2, 8. So for this one, we almost get that umbrella shape that we got with the x squared, but the only thing is the negatives are not positive. So remember the other one, it went up like this, but it would make sense for us to assume that it would have this shape, because the minus signs are eliminated in the squared, but in this one they're not, so you would have negative values. So some people might be able to see that right away. I mean, whenever you're doing these, kind of take time to kind of explore the graph and look at what the equation is doing, and then try to look at the graph and try to piece the two together. So that'll be really, really helpful in later sections. And I have one more that I really wanted to do, and it's a question with a radical. So I have y is equal to the square root of 4 minus x squared. So we have a radical here, and then we have also a number being squared. And there's a couple of things I could say about this, but I don't think anyone would have learned it in a previous math class, at least unless you haven't taken pre-calculus or any of these other things beforehand. Well, let's just start out by making the table, and we'll go from there. we'll do the same things again. So one thing actually I wanted to mention first, that I hope is at least one thing people will remember about radicals, is that we cannot have a negative number. We cannot have a total negative number underneath a radical, because what a radical means is so if I take the square root of 4, basically what it's looking for is two numbers. What this means is it's asking for what number times itself will give me 4, and that's 2. If we have a negative, so say if we had negative 4, this is impossible, because what it's asking for is what number times itself is going to give me negative 4. And negative 2 doesn't work, because negative 2 squared is equal to 4, remember? So what you'd have to, and positive 2 squared is equal to 4. So it's an impossibility. Later on in math there are things called imaginary numbers, and I'm not making that up. There are things called imaginary numbers. I think you learn about them I'm pretty sure it's a pre-calculus that you learn about them. I don't think we'll be learning about them in this class, but they have very limited use. I believe I saw a use for them in particle physics somewhere. It might have been a wave equation of some kind, but I mean, we're not even going to talk about it right now. Just for all intents and purposes, say that when it's impossible to have a negative square root unless it's imaginary, and there's a whole thing about that, but we're not going to talk about it. So can't have a negative number. And in this case, we don't have a negative number right now, but we would see that if, well, let's do all these first. So y is equal to the square root of 4 minus 2 squared. So minus 2 squared is 4, but then we subtract 4, so we get 0. So minus 2, 0. Y is equal to the square root of 4 minus 1 squared. So minus 1 squared is 1. 4 minus 1 is 3. So we have the square root of 3. Minus 1 square root of 3. So y is equal to square root of 4 minus 0 squared, which is 2. 0, 2. Y is equal to square root of 4 minus 1 squared. So minus 1, and it's going to be the same 1. So square root of 3. 1 square root of 3. And then for the last one, we're going to get the same thing as the top one. So 4 minus 2 squared. So 2 squared is 4, so we get 0. 2, 0. And that's where it stops. We can't have actually any other numbers besides this. So if we went to, let's say if we wanted to find out what 3 was, if we put 3 in here, we're going to get 3 squared, which is 9. And then 9, so 4 minus 9 is negative 5. And there's no number times itself, no real number times itself, that is going to give us minus 5. But also, if we went to minus 3, if we did minus 3 squared, that would also give us positive 9, and it would give us the exact same answer. So in fact, these are the only x's that would work for this equation. No other x's, greater or smaller, would work besides minus 2 to 2, because it would make a negative number under the radical, like I said, which doesn't work. So it was a kind of a tricky question. Let's graph this, and I'll have a couple more things to say about it. Not too many. But there might be a couple of interesting things to say. So first one's minus 2, 0. So that's right here. The second one is minus 1 square root of 3. Square root of 3 is about, it's about 1.5. I think it's like 1.6, no, 1.7 something. So we'll put that minus 1 and then like 1 and like somewhere right here, like 1.5. So then we have 0, 2 here. 1 square root of 3 again. So it's like, you know, a little, around a half. And then 2, 0. So when we connect these together, alright, that dark blue is kind of hard to see, but if we connect these together, I mean, this connection is quite terrible. And actually, we don't put arrows on the end of these because remember, it begins at 2, or minus 2, and then it ends at 2. We cannot have 3 or minus 3. I will learn more about that later. I don't know why. I mean, this problem might be a little bit tricky for this section, especially if we haven't talked about functions and all these other things. Yeah, that's probably a better place for it. But anyways, here we have it. And although this is terribly drawn, you will notice that it is in the shape of a half circle. And that's because this is the equation of a circle, which we'll be learning about shortly. I mean, you don't have to know this. This is just more out of interest. This is the end of the problem. The rest of this is just kind of bonus material, I guess. This is just so you can recognize it in the future if you're doing more problems. So we have y is equal to the square root of 4 minus x squared. So if we square both of these sides, we'll get y squared is equal to 4 minus x squared. And if we subtract this x squared over, we get y squared plus x squared is equal to 4. And this is the general form of a circle. Y squared plus x squared is equal to 4. And this is a, well, let me go on. This is a circle with a radius of 2. Actually, I probably shouldn't even start talking about that right now, but this is just out of interest. So if you see equations like this and you can solve it, you'll know that you should have a circle, and you might ask where the other half of this circle is. Well, in order for this other half of the circle to be drawn in, what I'd have to do is have a minus sign here, because then it would give me all the same y values, but then after you put a minus sign outside of this right here. So it would give me all the same y values, but then after that it would put a minus on it, so then it would give me underneath here. So that was a little bit of extra. This is just mainly to emphasize the properties of exponents and to give a quick reminder about negatives and radicals, because these are the kind of things that will cause you almost definitely to get questions wrong. Not really this whole plugging in numbers. That part is generally not going to provide a lot of problems for people. It's mainly these sort of little details that people tend to forget about. So if you're getting a lot of problems wrong in these questions, I suggest you go back over order of operations and just look over exponents and radicals and just kind of do a few, I mean, if you want, go back and review, or just play around with your calculator to see how the numbers work. I recommend when you do these graphs to check in your calculator, because it will, if you have a graphing calculator at least, it will give you an accurate graph. It will give you all these graphs we've done. And you can go to the table and it will have all the points in there as well. I wish I had a graphing calculator on this computer. I might be able to get one later. I've seen them before, but anyways, just make sure you practice all of the basics.